Hello, biology students. Today we will be talking about stem cells. This week so far, you've learned about mitosis and the various stages of mitosis and what's happening in each one of those stages and what they look like. Yesterday, you guys covered cancer and worked on, or at least started working on a project or assignment related to that. Today, we're going to look at what stem cells are and their primary functions. You may have heard of them before because they can be a controversial topic. They've also been in kind of the political realm as well. So if you have not heard of them yet, you probably will be in the future. First off, the definition of stem cells are unspecialized cells that can develop into specialized cells under the right conditions. So what we're talking about here are that cells that do not have a specific job. That's how I think of this. They're not given a specific job yet, but they can go into any type of job. Just like you, students. Most of you have not picked your career yet. So you are considered unspecialized. Once you decide in your career, you can become anything you want and you'll become specialized in that field. So unspecialized cells, undifferentiated, they don't have a specific function, but they can be used to become any other type of cell. Two main types of stem cells are embryonic and adult. And we'll talk about the differences between the two. We'll first focus on embryonic. Embryonic stem cells, like it sounds, comes from embryos. So 5 to 7 days after fertilization, you are an embryo called a blastocyst. You consist of about 150 undifferentiated cells. So 150 stem cells. They have not yet been given a job. They have not been given a task of what they need to do in your body or what they need to become in your body. So it's a ball of cells that are undifferentiated. These are embryonic stem cells because they come from the embryonic state. Why that's important is because these cells can be used to regenerate or repair damaged tissue or organs in adults. So they're really kind of magic cells in that you can take those stem cells and place them into other tissues, other organs, and they will become that tissue or organ of whatever you put it into. So if you have a bad burn on your arm, let's say, and you need some skin cells to be replaced, embryonic cells can be used in place of those cells and repair that burn tissue on your skin, for example. So again, we talked about those 100, 150 unspecialized cells in embryos or blastocysts that can develop into other types of specialized cells. Controversy comes into how those cells are viewed. They are embryos, so they are fertilized eggs. Where we get those, or where researchers get those eggs from, are in vitro clinics. So those folks that go into in vitro clinics to have the process of in vitro done, which is you are taking eggs from mom, you're taking sperm from dad, put it in a petri dish, they fertilize, so the sperm fertilizes the eggs in the petri dish to become embryos, and then those parents or those that are the doctors that are doing this look at the most viable options in that petri dish and say, okay, which ones of these are most likely to be viable, live, and survive? They are then placed inside mom. So like 2 to 3 of them usually are placed inside mom in hopes that at least one will take and develop into a fetus. So those that are struggling to conceive on their own are using, some choose to use in vitro to do that. Well, in that process, not all of those fertilized eggs or embryos are used in that petri dish. You can choose to freeze those embryos, or you may choose to freeze and or donate them to stem cell research. So that's where the embryos come from, or the embryonic stem cells come from, are donated embryos from, excuse me, excuse me, donate embryos from couples that choose to do in vitro and then not use all of the embryos that they have. Sorry, wow. frog in my throat. Moving on to adult stem cells. Here we go. The difference here is that embryonic, like we mentioned, come from that blastocyst of a bunch of undifferentiated cells. So very early on, they have not been designated a specific function or job in the body yet. Where adult stem cells, there's much fewer of them, and the potential for them to become other cells is minimal. So they lack versatility in what they can do and what they can become. So embryonic is really the stem cells that are being used and researched for that repair and regeneration of other tissues and organs. Adult or somatic stem cells just don't have the opportunity because most of them have already been specialized. And you have these already in your body that continue to repair tissues throughout your body, throughout your entire life. So these are important for you to have. We just don't typically use them in research. Some applications that we've already mentioned includes repairing damaged or diseased tissue and organs, including muscle cells, blood cells, nerve cells, so like Parkinson's disease, liver cells, you name it. Heart issues, intestinal, it can be used in many, many forms. And then lastly are some other examples. So bone marrow, stem cells can be used for helping to treat symptoms of leukemia or treat leukemia with chemotherapy. Skin cells with burn victims, islet cells for those with diabetes, myocardium cells, so that deals with your heart and heart disease, retinal for blindness, and like I mentioned earlier, those nerve cells for Parkinson's. So these really are pretty amazing cells that can become other cells and provide some major relief and major medical technology advancements in their research and studies. So that's stem cells and what they are, the two main types of them, and some examples of where they're used. There is a video linked in Classroom today that tells more about this, as well as your assignment. Your assignment today is to go to a Mayo Clinic website, which is linked, to learn more about what stem cells are and how they're used. And then there are, I believe, 7 questions to answer in classroom related to this topic today.